Good day, everyone. Welcome to Global Academy Institute Technology Foundation Incorporated. Our topic for second quarter week 1 is electromagnetic waves. Michael Faraday, 1791 to 1867, formulated the principle behind electromagnetic induction. Hans Christian Ørsted, 1777 to 1851. He showed how a current-carrying wire behaves like a magnet. James Clerk Maxwell, 1831 to 1879, contributed in developing equations that showed the relationship of electricity and magnetism. Heinrich Hertz, 1857 to 1894, showed experimental evidence of electromagnetic waves and their link to light. André Marie Ampère, 1775 to 1836. He demonstrated the magnetic effect based on the direction of current. Electromagnetic waves. Accelerating electrons produce electromagnetic EMR, electromagnetic waves. These waves are a combination of electric and magnetic fields. A changing magnetic field produces an electric field, and a changing electric field produces a magnetic field. As accelerated electrons produce an electric field of a wave, the varying electric field produces the wave's magnetic field. Both the electric field and the magnetic field oscillate perpendicular to each other into the direction of the propagating wave. Therefore, electromagnetic waves are transverse waves. Figure 1. Electromagnetic wave propagation. Among the examples of electromagnetic waves are radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, and gamma rays. All electromagnetic waves travel at a speed of 3 times 108 in a vacuum and denoted as c, the speed of light. Since all the electromagnetic waves have the same speed, as wavelength decreases, the frequency of wave increases as expressed in the equation, where v is the wave speed, or c, speed of light expressed in meter per second. F is the frequency expressed in hertz, and v is the wavelength expressed in meters. Speed. All electromagnetic waves travel at a speed of 300,000 km per second, 3 times 108 meter per second, in a vacuum of space. However, when electromagnetic waves travel through matter, they slow down. The speed of the wave depends upon the material they travel through. Electromagnetic waves usually travel the slowest in solids and the fastest in gases, as shown in Table 1 below. Table 1. Speed of visible light. Material: vacuum, air, water, glass, diamond. Speed: kilometer per second. Vacuum has 300,000 km per second. Air, slightly less than 300,000 km per second. Water, 226,000 km per second. Glass, 200,000 km per second. Diamond, 124 km per second. Frequency. The frequency, represented by the Greek letter Nu, v, is the number of waves that pass a certain point in a specified amount of time. Typically, frequency is measured in units of cycles per second or waves per second. 1 wave per second is also called a hertz, and in SL units is reciprocal second. Wavelength. Wavelength is defined as the distance measured from one crest of a wave to the next crest, or from one through to the second through. A wave cycle consists of one complete wave, starting at the 0 point, going up to a wave crest, going back down to a wave through, and back to 0 point again. The wavelength of a wave is the distance between any two corresponding points on adjacent waves. It is easiest to visualize the wavelength of a wave as the distance from one wave crest to the next. In an equation, wavelength is represented by the Greek letter lambda. Depending on the type of wave, wavelength can be measured in meters, centimeters, or nanometers. 1 meter equals 109 nanometer. To find wavelength, use this equation. Thank you for listening and God bless.